Hello everyone, today we are solving a Harvard University entrance exam math questions that many students searched for online. If you are preparing for Harvard admission math entrance test or competitive exam problem solving, so this one will help you sharpen your skills. So here we solve the equation k square minus k cube is equals to 36 divided by 3. So this type of equation often appears in Harvard math practice tests, algebra entrance exam questions, and university level problem solving drills. So before we solve it, I want you to jump into the comments and answer these questions. So number one question is that what do you think, does this equation have one real root or multiple real roots? Question number two is that would you solve it using factoring, graphing, or trial and error method? Also, you just tells me that which method do you think works best for entrance exams. And question number three is that do you think the correct value of x is positive or negative? And your answer helps boost your learning and also help others preparing for Harvard level math questions. So drop your thoughts below. All right, let's break it down. And now we move towards the solution of this problem. And first here we need to focus into the right hand side, and we write these into the simplified form. And when we cancel these terms, it will be written as 3 1s are 3 and 3 2s are 6. So we will obtain here k square minus k cubed is equals to 12. And further in the next step here, we need to write this into the more simplified form. So here we break our right hand side as this is k square minus k cubed is equals to this is 12, and we write it as 8 plus 4. Further, we write our right hand side into the prime factors form, and you know about that. The prime factors of 8 are 2 cubed and the prime factors of 4 are 2 square. And further we move both of these two values from right hand side to the left hand side, and it will becomes here k square minus k cubed, and this is minus 2 cubed minus 2 square, and this whole equation is equals to 0. And now we make the pair of square term with square term, and we have this is k square and the other square term is 2 square, and here we need to take common negative sign from both of these two values, and it will becomes k cubed plus 2 cubed, and this whole equation is equals to 0. And now here further we need the nice two formulas, and you know about that. If we have a square minus b square is equals to a minus b times of a plus b, and the second here we need the cubic formula. You know about that. If we have a cubed plus b cubed is equals to a plus b times of a square minus ab plus b square. So here if we need to use this formula on this term, and the base of this term is our a and the base of this term is our b. So here first we apply the first formula to the first term, and it will be written as first you have a minus b. Here our a is k and b is 2 into a plus b. Here our a is k and b is 2, and minus here we need to use the second cubic formula on this term, and the base of this term is our a and the base of this term is our b. So after applying this cubic formula on here, it will be written as first you have a plus b, it will becomes k plus 2 into this is a square. Here our a is k square minus a is k and b is 2 plus b square, so b is 2 square, and this whole equation is equals to 0. And here you see that this k plus 2 term is appears on both of these terms, so that here we need to take common k plus 2, and when we will take common k plus 2 we get the remaining values are, from here we get k minus 2, and from here we need to multiply this negative sign on each of these values, and it will becomes here minus k square. This is minus times minus becomes plus 2 times of k. This minus times plus becomes minus 4, and this whole equation is equals to 0. And here we need more simplifications, and it will be written as k plus 2 times. Here we have this is minus k square, and this is k plus 2k becomes here 3k, and this is minus 2 and minus 4 becomes minus 6, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k plus 2 equals to 0, and the second case is we write minus k square plus 3k minus 6 equals to 0. So from this case we easily get the first root of the given equation, and that is k equals to minus 2. And from here we need to write this into the standard form, and for this we multiplying both of the sides by minus 1. So when we multiply each of these terms by minus 1, it will be written as k square minus 3k plus 6 equals to 0. So this is our quadratic equation into the standard form, and here we need to use the quadratic formula to solve this problem. So for this we write first we write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to minus 3, and c is equals to 6. And we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and here we need to substitute all the values of a, b and c in this formula, and it will be written as k is equals to, this is minus b, the value of b is minus 3 plus minus square root of b square, b is minus 3 square minus 4 times of a is 1 and c is 6, and it is divided by 2 times of a, and here our a is equals to 1. So further in the next step we need more simplifications, and it will be written as this is minus times minus becomes plus 3, and plus minus square root of this is minus 3 square, and minus 3 square becomes 9, minus this is 4 times 6 becomes 24, and it is divided by 2 times of 1 is equals to 2. And here we need more simplifications, and it will be written as this is 3 plus minus square root of 9 minus 24 becomes here minus 15. Okay, 9 minus 24 becomes here minus 15, and it is divided by 2. So here further we break this square root sign separately on both of these two values, and it will be written as 3 plus minus square root of 15 into square root of minus 1, and it is divided by 2. And here you very well know about that when a negative sign appears inside the square root, it will becomes iota. So this minus 1 square root becomes iota, and it is divided by 2. So these are the other two complex roots of the given equation which we get here, and we have the one real root of the given question is k is equals to minus 2. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.